All right, welcome back once again, everybody. It's the Dr. Seifrit and Don podcast. I'm Don Seifrit. I'm here with Dr. Kari Peter. Say hi, Kari.
Hello.
And we're here with Dr. Holly Bartholomew. Say hi, Holly.
Hello.
So, Holly, you are with USDA-ARS out of Beltsville. We've had Dr. Wayne Jurek on a couple times previously here in the last couple weeks, and Wayne is the supervisor for your lab. That's right?
Yeah, that's correct.
Okay. So tell us a little bit about yourself, kind of what you do, how you got into what you do, and give us a little bit about your background.
Sure, absolutely. So I earned my bachelor's degree at Virginia Tech, and that was in microbiology. I then stayed on for my PhD with Dr. Ann Stevens, and that was focused on a bacterial pathogen of corn, Pantoea stewardii, that causes Stewart's wilt. And so that was kind of my introduction to plant pathology. I then, in 2020, earned my PhD and moved on to the USDA-ARS in the food quality lab with Wayne with post-harvest apple pathogens.
Okay, cool. So you're pretty local. You haven't had to ship yourself all the way across the country to be here.
It's been nice.
You're Virginia native then?
Yes, absolutely.
Cool. So you started on corn, but now you're working on tree fruit. Tell us a little bit about what you're studying now in the lab.
Yeah, absolutely. So the overall goal of the work that I've been doing is focused on a pathogen called Penicillium expansum, and that causes blue mold decay in apple fruit or in pome fruit. Apples are what I've been working with specifically. And the goal of my work has been to both reduce the incidence of blue mold decay and other rot pathogens in pome fruit, but also to reduce mycotoxin contamination that is caused by these fungi. And the mycotoxin that has been of interest to my group and me specifically is Patulin, and that is produced by blue mold causal agents.
Okay, so a lot of the folks that listen to this are producers and growers who might not be familiar with this. So could you explain what a mycotoxin is and what Patulin is?
Sure. So Patulin is a mycotoxin that is very common in apple-based products. And so this is things like juices, ciders, food for young children. It's a mycotoxin because it does cause a multitude of nasty conditions that have been studied using animals. And so this is acute toxicity, which can include shortness of breath, fluid buildup, gastrointestinal distension. There's also other symptoms that are more subacute toxicity, like neurotoxicity, so tremors and convulsions, weight loss, and digestive issues like bleeding, ulcers, and renal problems. And so the reason for these symptoms is because Patulin is a very reactive compound, and so it can interact with proteins that result in misfunction. And there's also been evidence that it interacts with DNA and causes damage and alters host immune response.
Okay, so it's a pretty nasty chemical compound that's getting produced. How common are mycotoxins? Is that like a very, very common defense mechanism?
Yeah, so there are many different mycotoxins that are produced by many different fungi, and in many instances, they, are produced for a variety of reasons, both to help gain entry and to help break down the surrounding tissue for whatever they're infecting. So it's important, not just from a Patulin standpoint, but the other mycotoxins that are out there, like aflatoxins or Don and those sorts of things.
Okay, so it's not just a blue mold problem. It is a kind of pan fungi issue.
Definitely much more widespread. Yes.
Okay. So why is it produced? Do we have an answer for that? What's the significance of this? Why would the blue mold produce this?
So that's a great question, and actually something that our lab has been working on recently. So the goal of some of my research has been to understand the toxin when it's in the fruit. And so we actually put the toxin in the fruit by itself without the presence of the fungus, and saw that it does create disease symptoms similar to that of the blue mold itself. So it causes some rot, some lesion formation to happen. Beyond that, we also showed that penicillium, so those that are for blue mold, do tolerate the toxin, but there are other common post-harvest pathogens such as those that cause alternaria rot, brown rot, gray mold, and bitter rot, that the patulin actually prevents them from germinating and growing. So this suggests that the penicillium do have a tolerance against the toxin, but that they might use the toxin to edge out the competition of the other fungi present.
Now, some people might be listening thinking, oh my gosh, I'm eating applesauce or drinking apple juice, and I'm going to get contaminated. So explain to people as far as how tightly regulated this, this mycotoxin is, to allay any fears that might be out there when people are grabbing that jug of apple juice off the grocery store shelf.
Yeah, absolutely. So as I mentioned, it does have a lot of toxicity, and so there's a lot of regulation that goes along with it. So many countries do have limits for patulin. In the United States, the FDA has limited it to 50 micrograms per liter, which is 50 parts per billion of patulin, so very low amounts. This limit does change depending on country, so that's also an important note for if you do have exporting and that sort of thing to consider for your business.
And for baby food too, I think it's even lower.
Yes, I think in the EU it's down to 10 parts per billion, if I'm not mistaken.
So to follow up on that, do all penicillium species produce patulin?
No, they do
there's
not.
a lot, because there's a lot of, based on Johanni's work, who we had on in the very beginning, we're finding a lot of different penicillium species. The dominant is expansum, but penicillium is quite ubiquitous, and so that there's a lot of different species out there. So I'm just curious as far as, what's the general feel for patulin and penicillium in general?
Yes, so you're absolutely right. They don't all produce patulin. Penicillium expansum is one of the major producers of patulin, and Penicillium griseofulvum is another one. And both of them are found in apple and apple-based products.
So that's really interesting. As you were talking, and I'm going to go back a little bit to what you said before, it's that suppressant. I was just thinking of it kind of as juglone that walnut produces to kind of suppress all of its competition. So I think it's really interesting that the penicillium is producing this toxin to do the same kind of effect.
Yeah, absolutely. And one other thing I do want to note, actually going back to Kari's question, is we did show that there are penicillium species that don't produce patulin that do tolerate this toxin. So it does seem to be a genus-wide tolerance, at least from the different organisms that we've looked at.
So are there any ways to reduce patulin in juice and processed products that, if there is contamination, what can folks do to kind of reduce those levels?
Yeah, absolutely. If you do see it in your processed products, there are some ways that can enable the reduction to safe levels. For many apple products, the processing stages will actually help reduce it. So pasteurization, enzyme treatment, microfiltrations, evaporation in apple juice. But these are only partial reductions. Each step individually can build up to a large amount of reduction. Pulping also helps to reduce patulin, clarification. There are also methods using adsorption, so things like activated carbon and resins that can bind up and remove that toxin. UV radiation has been shown to help reduce patulin, and even other chemicals, so ozone, ascorbic acid, and biologicals as well. So things that can degrade it, like there are certain yeasts that can, or again, more adsorption technologies using bacteria.
So if I'm a new processor, for example, and I want to get into, let's say, the applesauce business, how do I go about testing my product for patulin?
Sure. So there are rapid patulin detection tests. They're called ELISAs. These are immunoassays that can be purchased online for use. They do still require some smaller lab equipment, so that is something to consider. There are also a few analytical chemical detection methods for patulin that can be carried out in a laboratory. And so after doing extraction processing, you can use what's called high performance liquid chromatography, or HPLC, that can help you quantify the patulin.
So what you're saying is, if I'm a new producer, I hire a lab to do these things for me. I'm not doing it on my own.
Right. I would highly recommend that you find a lab that can help you with this.
Okay, cool. Yeah, as you started saying, you were like, oh, there's a test. I was like, oh, okay, sure. And then it was immediately liquid chromatography. And I was like, okay, well, there's the rub.
Yes, for now, that is still one of the drawbacks of these processes. But
Cool. So how does your research aim to reduce patulin contamination?
the practical implications from my work are to try to understand that tolerance mechanism that the penicillium have against the patulin so that we can hopefully try to exploit it to make them sensitive to their own toxin, to either stop the growth of the fungi themselves or reduce the toxin that is produced by the fungus. We also are hoping to find perhaps a derivative of the toxin in order to reduce other fungal infections that maybe isn't quite so toxic to others, like people that are going to be consuming this. And then from a biological control perspective, if you are going to be using biocontrol organisms that would be of interest to combat blue mold, you would potentially need them to tolerate that environment, which might include toxin presence. This would be, something that's important, although if it's applied prior to the heavy infection, that might not be as big of an issue, but also considering organisms that can detoxify the toxin in that post-harvest space, like in the juices and processing facilities, like those yeast and bacteria that I mentioned before. It's good to know what can tolerate it and what can break it down. And so by understanding the role of the toxin in the fungal biology, we do hope to find more ways to prevent the production or accumulation of patulin.
Cool. I think it's really interesting, and you have the benefit of being kind of the last person on. You have all this building up, but that your lab as a whole is doing so much reduction to really reduce threat overall, right? It's kind of like levels of filtration down to our end product, right? Our value added product. So it's like reduction in blue mold spores up here in the bins and in the field, and then it works its way down. And then it's like the last line of defense kind of is some of the work that you're doing. And you can correct me if I'm wrong about that.
Yeah, no, exactly it. That's exactly it. And then also hoping, again, that some of the work that I am also finding can be translated back to stopping the blue mold before it even gets going.
Like I said, that's really cool. And when we had Wayne on to talk about the lab itself, you guys are a tight lab. There's only, he said, like 6 of you in there. So that's a lot of really cool work on a very specific thing that just a very few of you are doing. So
yeah, definitely. I think it's been a really good group to work with as well. And, I like that we have really been trying to tackle the problem from all these different angles together.
So we've talked a lot about your work itself. What is your favorite part of your job? What do you love about being a plant pathologist or a microbiologist, I should say?
Yeah, absolutely. Great question. So I'm very passionate about improving food quality and quantity. And this has spanned, from my graduate career, both from in the field and also in post-harvest storage. Beyond that, as a scientist, I do love the science of the work and trying to solve the mysteries of these interactions so that we can prevent these disease occurrences and toxin production.
Cool. And I know Wayne said you had been with USDA, I think about 3 years, he had said.
Yes.
So what are kind of your long-term goals?
Yeah, great question. So I am hoping to continue working in the realm of plant pathology to, again, solve the problems of either post-harvest storage or even in-field work. Where it will take me, I am not yet sure, but I'm enjoying my time while I'm here.
Cool. Well, I'm really glad that y'all could be on and we could ask you guys a bunch of questions and pick your brains. And you missed a couple of the other weeks, but I got some real left field questions in my brain and I asked them, and you guys were always so gracious about answering them. It was really nice.
Yeah, it's been great being here and talking about this.
The one thing that I just sort of wanted to bring home to the grower, particularly the growers who are listening and who do storage, who have cold storage, during the winter meetings, if folks attended the winter meetings, one of the things I talked about was bitter rot and preventing bitter rot pre-harvest, because it can show up during storage. And when you have rots during storage, it can be an entry point for blue mold, because you basically said that because of patulin is a strategy that blue mold can basically elbow out anything in its path. And so, I'm really glad that you had described that, because trying to get growers to be thinking about the disease management even post harvest but not only that, but we have so many rots that can show up post-harvest that started pre-harvest. And that the fact that, what people don't also, I think folks may not appreciate as well as they probably should, is that if you have cold storage, blue mold is existing in there. It's just a resident fungal organism. And, there are methods to try to lower that incidence, but it is there nonetheless. And all the more reason to be real mindful of how you control disease pre-harvest so it doesn't show up post-harvest is the fact that any wound that's occurring post-harvest will be an entry point for blue mold, because penicillium, as a beast as it is, it can't force itself into the fruit like some other fungal organisms. It needs some kind of opening, whether that's a wound or a puncture or, through the stem end, but it needs an entry point, and rots can be an entry point. So folks, as my take home message, everything that Holly said here, be mindful of how you're thinking about controlling your rots pre-harvest, because it will pay off in the post-harvest, because especially for folks who have fruit that are destined for processing, you might be in for a rude awakening, when stuff is being tested, because you could have lots of apples that could be rejected as a result of it exceeding the threshold for patulin. So, just as a reminder, patulin, it's a mycotoxin, it's tightly regulated. Whoever's processing, they will be monitoring this. And I think Holly did a great job explaining sort of just how nasty this is, and how it functions, once apples do become infected. And the fact is that we do have researchers that are on this, trying to how to minimize patulin, how to sort of thwart that process. And yeah, so I think it was really good. I think from the very beginning to as far as how Johanny described all of his research and what he's learning and what he's studying to this point, as far as really the end goal of blue mold and how it sort of elbows itself into the fruit, regardless of what other fungal organisms might be there. It's kind of a nice full circle discussion here. I hope that made sense.
Yeah. All right. Well, thanks, Holly, for joining us today. Super grateful to have you on. I think folks learned a lot. I know I did.
Thank you for having me. I'm glad to talk about the work that we've been doing and to help people understand the problem that is patulin.
Yeah. So, wherever your career in plant pathology takes you, whether you stick at USDA for, I don't know, the next 30 years, or if you, wherever you go afterwards, if you want to come back, we'd be more than happy to have you.
Absolutely. Thank you for that.
Yeah, no problem. All right. So I think that's it. This is the end of our post-harvest rot series. Thank you guys all for listening. Hopefully this was interesting to you all, as interesting as it was for me to host. And if you really liked this, let us know, so that way we can do more of these type of series, because we do a lot of fruit bites, a lot of digestible short things that's really applicable to stuff in season, but this is maybe a little more academic. But like I said, I had a really good time recording it. So if you guys really like this, please reach out to Kari or myself and let us know. So, all right, Kari, Holly, let's say goodbye to everybody.
See you later.
Bye.
Thanks for listening.